Hello, everyone, and welcome to my Tech Talk. We're going to be talking about how programming is changing live entertainment. All right, great. Let's get started. Hello, my name is Ken Kurosaki-Rodriguez. Probably should say that as a professional would. And a little bit about myself before we begin. I'm actually from Sasebo, Japan. You can find Sasebo on the lovely island of Kyushu, located on the west side of Japan. Very beautiful. And of course, a little bit about my experience and passion. Esports, content creation, and broadcasting. That was the fields that I was working in before I joined Code Chrysalis, and kind of the thing that really sparked my passion in technology and programming. And I want to do something for the community centered around this. Just love communities and their energy. So I was like, you know what? Let's try some programming. And here we are at Code Chrysalis. Thanks for having me. All right, let's get started. Okay, first, let's get started with this quote. Saint John said, pop culture and entertainment can be dismissed as surface, but it's not. It's the language we all speak, and it's connection point between people all over the world. And that's so true, especially today when we have things like smartphones right in our pockets. When a video goes viral, everyone talks about it. They use the lingo from it. They perform the actions from it. Entertainment really is a connecting point for people all over the world. And it's extremely powerful, which is why I'm so invested in it. So let's talk about video entertainment. First of all, we have shadow play. I think everyone's done this with their hands, making dogs and shadows such against the wall, but it's actually a very important cultural aspect for all of us. Way back in the day, it was a form of entertainment. Then we moved to stroboscopic discs around the 1800s, where it would basically be images on sticks. And if you spun it really fast, it would make the illusion that it was actually moving, but it would only last a few seconds or so. And now here we are at present day, where we're basically taking the stroboscopic disc and making it more powerful by flashing images in front of your eyes really, really fast to, I guess, create the illusion that something is moving. And, you have your cinema at 24 images per second. And you have video games up to 300. It depends on your hardware. But now let's talk about the living room and changing the industry of entertainment. And here it is, a picture of the nuclear family, the traditional nuclear family, sitting around their very big television of about 3 inches. And this is kind of an important time around the 1950s when television really became popular and you don't have to go outside anymore. Entertainment is available indoors. And it was a great time for content creation. A lot of dramas, Westerns, quiz shows were really developed during this time. So it was huge for entertainment. Then we had the VHS, the video home system, which was invented in 1976 by a Japanese company. Could hold about 120, 160 minutes of data. And you didn't have to go to cinema anymore. You could just watch it at home with your family. And of course, we got our DVDs and Blu-rays when these mediums became more versatile, as DVD stands for digital versatile disc. And you could put your music on there, your software on there. By music, the ones that you definitely purchase legally, of course. And of course, we got Blu-rays, which held so much data, up to 250 gigabytes, and could produce images in 1080p. Really an amazing piece of technology. And it's great looking at these physical collections. However, there was another war being fought on another front, and that is media streaming, the digital front. So let's talk a little bit about that. With H.261, you can kind of see the picture here. 261 was actually the first practical video coding standard. And it was used for, you guessed it, video conferencing. Just like the internet, when it was first invented, it was kind of used by intellectuals and professionals to share data. Well, 261 was just used by professionals and to have meetings over the internet. But that quickly moved on. And now we have MPEG-1, parts 1 through 5, to produce beautiful high definition images like the one here on the left. If you remember Netscape. And this is what allowed us to view videos and listen to audio on the internet. So if you take a look at MPEG-1, parts 1 through 5, MP3, that might be familiar, especially if you were born around 1991, like I was, with iPods becoming very, very popular. In the 2000s, you're able to listen to music without the actual physical CD, again, that you bought legally. And now here we are, present day, with 264 and 265. H.264 is currently the most popular video coding standard. It's actually called the AVC, Advanced Video Coding Standard. And it's used by 90% of business in the industry as of 2019. So it is exceptionally popular. And the magic of 264 is actually how flexible it is. So if you have slow internet, a low frame rate, or high bit rate, it doesn't really matter. 264 can actually video encode it. And it was great. So you might be asking, what about 265? Well, actually, 265 is great. It does everything that 264 does, but better. But it's just too expensive computationally right now. So if we were to unleash it, maybe if YouTube were to use it suddenly, then we'd all be looking like this. And maybe only the most powerful computers and best internet providers can actually access these websites. So it's going to take time to catch up the hardware and the internet speed before we can fully utilize 265. And it's just going to be like the television, right? When there was standard definition and now high definition, we just have to wait for the standard to catch up. So we've got great things to look forward to. All right, now let's talk a little bit about H.264 and about how it works, the magic behind it. So first off, we have prediction. This is the first piece of the pie. What needs to be compressed? So let's have an example here of a lady standing in front of a camera, and she's actually standing in front of a one color wall. And as you may know, walls don't tend to move very much. So that's where the magic of prediction begins. It knows that if something is moving or not moving. So if it's not moving, like this wall, it doesn't need to look at that space again. So it's only focusing on the moving element, like me in front of the webcam. As opposed to, there we got the race cars on the right-hand side where everything is moving, the background, the cars, the foreground, and it needs to look at all the pixels or polygons, whatever it may be, again and again and again for every single frame. That's why when you're making a Zoom call with your grandma or your boss, if you're like this gentleman and you kind of move your hand in front of the camera, it needs to render that and it might start to look a little bit blocky. More on that later. But you can kind of see on the background where the wall is not getting so blocky because it's not re-rendering those frames or that image or those pixels again. So prediction, magic. All right, now let's take a look at step 2 with transform, and we are compressing at what quality? So this is where the jargon comes in, but we got a very simple scale here to show you how it works. So on this scale, we have 2 weights, one on the left and one on the right, 2 boxes that are tied down to this. We have video quality on the left, and we have file size on the right. And in the middle, acting as the weight, we have quantization parameter. Just think of it as QP, and it's a weight. And this QP can either go to the left or to the right to prioritize one or the other. So if QP is very high, it's very heavy, then the file size will be shrunk, but at the cost of video quality. If we go to low QP, then the video quality will be excellent, but the file size will be extremely large. So it's kind of a fine line that you'll have to walk with quantization parameter. And transform does this in blocks. That's why we saw the GIF earlier. It gets a little bit blocky because it works in blocks. Great. All right, now we have the whole pie. We have prediction, what needs to be compressed. Next, we have transform, compress at what quality. Then we package the whole thing with encoding. We send it over and it gets decoded on your computer or maybe your phone. It's rebuilt according to specs, and then you can enjoy that great content on your smartphone. Great. And now we also have the streaming services. Some of these, maybe all of these, I'm sure you know. We have Prime Video, which is very, very popular here in Japan. And we have Netflix. Maybe you never heard of that one. We also have Hulu, which is also very, very popular. But there's one thing that's about these that's different than my tech talk, which is that they're not actually live, right? I mean, they're stored first, and then the content is delivered to the audience. They're not just going to film Brad Pitt and then send it to you right away. We have to process and edit. So it was at this moment that someone had a big moment, a big thought. So taking the magic of H.264 and then thinking about the content flow of coming from the user or the broadcaster company and using a content delivery network to distribute it to a wide audience, they found a new dynamic to kind of combine company and audience into one, which is a community and having interaction between the two. Now, this is huge. Now we have the birth of live streaming services. You might know of YouTube, maybe Mirudomu or Nico Nico Doga. but we're going to be talking about one that really focuses on live interaction, which is called Twitch.tv, formerly known as Justin.tv. And it was founded in 2007 by Justin Kahn, Emmett Shear, Michael Sabel, and Kyle Vo. And it only had one channel at the time of its birth, and that was for live casting. And it is as significant as it sounds and as crazy as it sounds. It's basically a channel in which you can see every moment of Justin Kahn's life on camera. So they actually used a laptop connected to a camera to put on top of his head, and he live streamed his life to the world, except for some moments, of course. And the thing that was so different about this experience was that there was an interactive chat that Justin could see, and other users such as yourself could actually type so Justin could see and interact with. And that really had a chance for viewers to influence Justin's behavior, something that wasn't seen before. And in fact, it was so interactive. Sometimes people watching on the other side of the internet would call the cops with fake warnings. But this is a new frontier and it needed to be explored. So of course, there's some downsides to it. But let's talk a little bit about Twitch.tv and how significant it is, especially when it comes to live entertainment and video entertainment. It's got over 2 million broadcasters at the current time, and it's got over 15 million daily viewers. And how much traffic this website gets is actually insane, for lack of a better word. It's got 67% of content hours watched and 90% of content streamed on the internet. So just so much data flowing in and out of this website and their servers. So why does this really matter for live interaction and for programming, changing live interaction? Well, it's the, excuse me, it's the fact that we can do just that. So we have chat, which we talked about before, but now there's a new one, the notification system. So if you see on your right-hand side here, this is an example of a notification. You can kind of see follower and library master is now following, and it's kind of overlaid over the content. These are live notifications, and they're somewhat of an instant interactive perk for viewers, which are fully customizable. And you can use CSS for them. So you CSS heads could definitely have fun with this, but it really depends on the action of the viewer. If they follow, if they subscribe, maybe they donate, or they perform another action, then overlaid over the content will be this instant live notification. And what's also significant is the business potential. There are now big companies that actually just focused on live notifications, and now they're quite big. So this really changed the industry here. And now there's just companies that focus on getting fully customizable notifications easily to broadcasters. All right, next, let's talk a little bit about extensions and kind of gamifying interactions to add an extra layer of content. We could kind of see on the right-hand side here a short GIF of someone using an extension, and these are programmed by businesses and users, and it's a little bit of a front-end custom experience. So you can kind of see on the right-hand side here, this is called Toby Ghost, and it actually tracks the eyes of the broadcaster. And as a viewer, you can actually change the color. You can actually change if it's a heat map. And this is really great for, of course, for jokes and seeing where they look, but maybe the viewer is a professional esports player and they want to kind of see where the other players are looking to gather data. It's just another way for a viewer to interact. And this could be completed or done by a professional or a casual programmer. And now let's talk a little bit about Overwolf, which is another example of an extension. Basically, it's a tech platform for overlay apps. You could kind of see all the data here on the right-hand side with for in-game stats live for a video game called League of Legends. It's a competitive video game, and numbers and stats are very, very important. But of course, you can also have a good time, not to just learn on the fly and be competitive, but also for communications, talking with random people who are also playing the same games as you. And of course, we can't go without talking about the business opportunities and how big this has really gotten. So if you also want to make your own project, it could possibly get funded. You just have to present it to Overwolf, and they'll give you access to their API, and you can start building a community around a game that you love as well. Really changing the industry here. Last, we have miscellaneous, which is creating unique experiences utilizing the Twitch API. So I was exploring GitHub and found Comfy.js, which was made by InstaFluff. And you can kind of see here an example of InstaFluff's Comfy.js library. And if you type ye claw with an exclamation point, you could kind of see the Rust crab kind of doing a little dance there. And this is just an extra way for viewers to have interaction with your channel, and the programmer can actually have full customizability within the realms of Twitch. And it doesn't actually end there as well. You can create bots such as the Stay Hydrated bot that kind of reminds you how long you've been live and how much water you should have drank as well. Everyone should drink water, stay very healthy. But it's pretty much unlimited in terms of programming and customizability. And we've seen how far things have come. The industry is really shaping up, especially when it comes to live entertainment. So there we go. We have the ways to create live interactive content with twitch.tv. But what are the challenges that could be presented? Well, first of all, we have latency. It's going to be a battle that I think we will always have to fight forever and ever, as long as technology is here, especially if we have to send data. And that just depends on how long it takes for the broadcaster's data to get to the server and from the server to the viewer. But advancements in programming have really cut that down quite a bit. It used to be about 50 seconds, but now it's hovering around 30 seconds, maybe about 5 seconds, depending on the hardware and speed of your internet and settings as well. And we have a couple more challenges here. The first one being net around the world is limited, as kind of the point that we just made previously. In Japan, maybe you're very lucky with 1 gigabyte per second, but other places such as Australia are still hovering around 30 megabytes per second. So we have to wait for the world to catch up. And that goes right into my next point, which is hardware limitation as well. When it comes to hardware limitation, this is quite serious. And it's going back to the point of H.265. It's going to take the world a little bit to catch up in terms of hardware limitation, in terms of speed, in terms of computing power, and of course, when it comes to 265 and being able to render all that data at one time. And finally, we have patents, royalties, and copyrights. Business is business, but with that comes a few toes that you may step on. H.261 currently has no patents available anymore, so you could go ahead and mess with that. But with new and upcoming technologies, AV1, 264, 265, we have to wait a little bit and contact businesses in order to ensure that we don't step on any toes while we advance technology and also advance live entertainment. Well, ladies and gentlemen, that's going to be the end of my tech talk. I hope you found it educational and fun. And if you're interested in exploring Comfy.js, which is InstaFluff's repo, you could check it over at the bottom link there at github.com/instafluff/Comfy.js. Overwolf as well. You could just go ahead and Google them. And if you want to find me, you can find me at KuroKen91 on GitHub or Kuro_Ken_Chan on Twitter. Thank you very much, everyone. Have a great day.